is even more exciting to me from the standpoint it's a brand new platform that we're building, and 40% of the .NET Core developers are actually new developers to .NET. And that was one of the reasons we actually built .NET Core, was to actually attract new developers. We open sourced all of our technology a couple years ago, and you can kind of see this growth that we have here that's happened. I don't know if Hansman showed any of these things yesterday or not. I'll quickly get through this stuff. This is my favorite one. We open sourced .NET Core in late 2014. We were measuring how much open source activity in our repos was outside of Microsoft. And this shows, we basically based this on a couple of things. If you did a pull request, you got 10 points. If you filed an issue, you got 5 points. If you actually wrote a comment, you got 1 point. And we measured this in 2015, and then we showed 2016. You can see it kind of explodes. A good chunk of our .NET Core and .NET Core and .NET open source ecosystem is actually starting to thrive, which we're really excited about. This is really exciting to me as well. When I took over this job earlier this year, we were just in the process of acquiring Xamarin, and that kind of makes .NET a full .NET for me, because we've always had the ability to build Windows applications. My team a couple of years ago started building .NET Core so we could do cross-platform server applications, and with Xamarin, we now have mobile applications as well. And in the future, you'll probably even see IoT show up here as well. And the goal is anything you want to write, we want to have .NET be the platform that you can write something in. And this kind of shows the 3 big .NETs that we have right now. And I'm going to talk about how we're going to take these .NETs and make them more compatible with each other into a kind of a unified platform. I'll talk a little bit very briefly about .NET Framework. Obviously, .NET Framework is our Windows framework. It's actually, Scott I think showed this yesterday, it's actually in a Windows folder on the machine, so it's a Windows component. It ships as part of Windows. And so as part of that, we only can rev .NET Framework a couple times a year, whenever Windows does a new update. And so it moves at a slightly slower pace than some of the other stacks that we have. This is crazy. I don't know if anybody's even aware of this. Do people know that we actually added long path support in 4.6.2? Finally, 20 years after we shipped .NET, you can actually do long paths in .NET. We added some cool capabilities where if you have a WPF application, it's now multi-monitor aware. It'll actually change its resolution as you move it across two monitors of different scope. And if you're a ASP.NET customer on system.web, we keep opening more things up to do async stuff in. So we added support for async in our caching providers. And another cool thing, I know I got a friend that's sitting over here that's been doing some .NET stuff for a while. We have this Windows Store shipped with Windows 10. And there hasn't been a way to actually take an existing .NET application and put it in the Windows Store. So if you have a WinForm application or a WPF application, there was no good way to do that. You had to write a new UWP application, which is great, but all of us have a lot of old code probably, and you want to be able to take those old applications and put them onto the Windows Store. And so we just announced a few months ago what we call Centennial, and it's actually a bridge where you can actually take your existing .NET Framework apps and run them in the Windows Store. And you might ask, why would I want to do that? Well, one of the biggest challenges of a .NET application today is how do you actually get it onto a desktop in your organization? You probably write your own setup, your own installers. You probably have somebody in IT that goes around and installs it on machines, or use some form of Windows server tech to actually push it. With the Windows Store, you actually can get a private Windows Store for your company, put your applications in there, people install it from the store, and they get updates automatically via the store mechanism. So that's pretty cool. Another thing is, in the app development space today, we see a lot of talk about containers, Docker containers. Containers have existed for a while. They've been primarily Linux-based. A few weeks ago at the Ignite conference, we announced that Windows Server 2016, which is now shipping, has support for Windows containers. So you can take your existing ASP.NET, Web API, WebForm, SignalR applications and run them untouched in a Windows container. And I'll drill in why that's kind of cool. So let me just step out here, and I will do a quick demo of Windows containers. So and I'll talk about while it's building, I'll talk about why it's cool. So I'll come in here and open up this is a system web-based ASP.NET application. It's actually a web form application. It's almost the default template. I made a super small change to it. In my main page, I go and find out what the OS is, and I show the operating system on the screen. So if I run this, It's going to be like the default ASP.NET application, and it's going to show you, hey, it's running on Windows 10 Enterprise because that's what my machine's on. Now, this app's a little different, and I'm going to show two ways of doing this. This app's a little different from the standpoint that I've added a file to it called a Docker file. And Docker file is right here. And we'll open that up. And you're going to see a couple things here. First off, what it says is, says from Microsoft ASP.NET. And that's called the base image that my container is built on. And I was just showing there's a site called Docker Hub that contains these base images. And here's my Microsoft/ASP.NET image that's up there today that people can actually use. And what that is that's a Windows 2016 server image. And then we installed .NET Framework 4.5 on top of that. And we installed ASP.NET on top of that as well. And so that's basically a pre-done VM kind of sitting up there in the cloud for you. Now, where Docker gets interesting is I can then take these files and compose these things. So I start with my from Microsoft/ASP.NET. That's my base image. I say I want to expose a port, so that's port 8000. I create a folder in the image. And then I say I run some PowerShell to basically tell IIS to go make me a web application in that particular folder. And then this says add my application to that thing. Now, what's cool about this is building VMs typically is not a fast thing. If you're building VMs today, you probably start with a blank machine and you install Windows Server, which takes a good chunk of time. Then you go into that VM and you install all the software that you want in the VM and you go and save it somewhere. That's a tedious process and typically takes hours to do today. In the Docker world, I can do all that in a matter of seconds or minutes just by writing files that compose these things. What's even cooler is once I have this file, it means I can actually develop on my local box on Windows Server 2016 without even setting up any VMs or stuff like that. The Docker stuff will actually run locally on my box and let me actually run all this stuff inside of a container. Where containers get cool for web developers, the cool thing about a container is they're very easy to scale up. I can take this file, go blast it to a bunch of servers, and the image will boot up, and then I can tell that server to scale that image multiple times on itself. And so I have customers that actually have large applications, and when their business builds up, they might actually spend a couple days getting their business ready for a big event that's going to happen. In the Docker world, scaling up ends up being seconds, not hours of work to do. And as a developer, what's cool for you is you can easily just develop on the server operating system on your local machine. So what I'm going to do here is I'm going to do this from command line first, and then my next demo will actually show the VS tooling that we're building on top of this, because I want to make this super easy to do in Visual Studio. So I'll just go to my application here, and I'm going to start Docker. This boots up the infrastructure. You can see the little whale down here saying that the Docker is starting. And we'll wait for it to start here. And I'll take Docker images. It says it can't do it yet because it's still waiting for Docker to start. So what the whale is, that's actually the admin that you actually have for managing containers. It's kind of a daemon that sits on your machine and will start and stop and do all the things that you want for containers. Come on, Docker. I will try to restart it in a second. I've never had this actually happen to me before. Docker is running. Of course, I told it to stop after I started it, so now it's going to do that again. Yeah. Hopefully it starts faster the second time. And this daemon is cool. As of the Ignite conference that we're at two weeks ago, the daemon used to actually only do Linux containers, and now it does both Windows and Linux containers. So once it starts up, I can actually right-click on it and say, switch from Linux containers to Windows containers. So on my box here, I can do both Windows and Linux and easily switch back and forth between these things. Come on, whale. Success. So that's showing on the screen there, that's showing my Linux containers. And I'm going to switch Docker to run Windows containers here. You see there's a menu here, switch to Windows containers. And that will stop all the VMs that I might have on the Linux side and switch to Windows. That went fast. Now if I type Docker images, you now see that Microsoft ASP.NET, the one from the Docker Hub that I found earlier, sitting up here. So I'm going to start and do this command line the first time. I'm going to say docker build -t my app. So what I'm telling it is to take that Docker file and run it against that Windows, that Windows image in my current folder. That's going to take that Windows image. It's going to merge my stuff into it. And you can see it running these commands. There's the from. It grabs the base image. It exposes the port. It is now running, it created my folder. The next step it will actually do is run the PowerShell to add IS to this thing. And as developers, as I said, what's cool about this tech is you can actually build these things by hand with all the directions of how to build your VMs. And you can actually have one VM depend on another VM. So I could have easily decided to make my container depend on another container, and it will boot both of them up on the machine for me. And I can basically recreate my entire environment on my local box that I'm going to run in production. And these same files are the files you're going to use in production. So whatever you're doing here works exactly how it will in production. And we have quite a few ways of running containers at Microsoft. We have obviously Windows Server. We have Azure Container Service in Azure, so you can actually run your containers in Azure. And we have a couple more pretty cool things that we're going to announce in that space as well. My machine is slow as death. So there we go. It's actually added the IIS to this thing, and that's good to go. And the next thing it's doing is basically copying my application inside the container. And once I'm done, I now will have a new image. I can say, show me the image. There's my app. Now I can tell it I want to start my app. And I will say, run in the background, my app. That will then boot up that Windows image on my machine. And as I said, I'm going to show, after I do this command line thing, I'm going to show how we have really, really awesome tooling in VS where you can basically right-click on your project and say, I want to add Docker support to it. We'll add all the files for you. There my image is running. Now I can actually say, show me all the processes. So you can see that it started up 8 seconds ago. There's my app. And in my case, I want to actually show the web app. So I need to actually find the IP address of my container. So I can say docker exec, give it the identifier for my container, say ipconfig. There's my IP address. Let's go up here. Go to port 8000. And pray. So the Docker support on Windows 10 is very beta-ish at this point. Once it gets going, it's actually pretty awesome. You'll see the Linux containers are a little bit more robust at this time, but hopefully this will come up. Oh, come on. I'll give it one more shot here, and then I will move on and talk about core. This was actually working just 20 minutes ago. What I'll do is I'm going to switch back to the deck and see if it just wants time to do more stuff. So the next .NET we have is we have .NET Core. And this is something that I started working on a couple years ago. This started with ASP.NET 5 many, many years ago. And the need, we found there's a need that there's a couple problems that we have with .NET Framework today, which is it's installed Windows globally. And so a lot of my customers say, hey, I can't use the latest version of .NET because it might break an existing app on the machine. So a couple of the tenets that we have with .NET Core was to make it self-contained. So it doesn't actually sit in Windows. It actually sits, as Scott would have showed yesterday, in your program files. So it's completely side by side. You can have as many on your machine as you want. You can actually install it in the app if you want as well. So it's got that capability. The other thing is, we knew, especially with the container work that's going on, the container world, that support for other operating systems was super important. We have customers that actually have data centers in Linux, and they have .NET applications, and we want them to be able to run there. We also have developers that have Macs, and they might want to develop on a Mac, and so that was something that was important to us. One of the frameworks to be super fast. I always ask people at these kinds of conferences, what's the fastest framework? And a lot of folks have this idea that Node.js is super fast. It's not. We're quite a bit faster than Node. Go is a lot faster than Node. Java's a lot faster than Node. So there's a lot of frameworks that are quite a bit faster than Node. As somebody that worked on the ASP.NET platform for many years, we built ASP.NET as a monolith. We basically turned every feature on by default. And so even if you were trying to build a very simple app, we ran lots of code that actually slowed your app down. So we actually decided to stretch things apart and make them much more modular. So you now turn things on as you want them. And of course, it's open source, as we've talked about. I don't know if Scott showed this yesterday, but this is the perf that we have today. You can see Node, Java, Go, more Java, and then .NET Core. And we're doing work to make that .NET Core probably go twice as fast as it is today. So there's still stuff coming in the pipeline here. This is a game, but I'll skip over this. We shipped .NET Core in June with preview tooling. We'll have the final version of the tooling sometime early next year. We just shipped a preview earlier this week of .NET Core 1.1, which brings in a bunch of new stuff for ASP.NET and a bunch of new things for Entity Framework and a bunch of bug fixes. So we're in the process of adding more of the stuff that was missing in ASP.NET back into .NET Core. And in EF, we're doing the same stuff. So that's kind of the direction we're taking with the platform. This is interesting. The way we ship .NET Core is going to be a lot different than the way we ship .NET Framework. As I was saying before, .NET Framework ships as a Windows component, and as a result, it can only ship when a Windows release ships. With .NET Core, we're going to adopt a new approach. There's going to be two ways that we ship. We're going to have what we call a long-term branch. That's called LTS. And you can take an LTS version like our 1.0 that we just shipped. That will be available and will support it for probably a period of about 3 years. And if, as a developer, you can decide to stay on that version, that's the RTM version, or you can decide to move to a faster paced version that we have. We're going to have what we call current. And the way current works is every 6 months there'll be a new drop of current. We shipped in June. Our first update of current is going to happen in November or December. And the next version, which I will actually talk about in the slides as well, will happen a few months down the road. And so the idea is if you're on current, you have to always stay on the latest current one. So then there's a 1.1, you have to move to 1.1. If you want to move to, when there's a 1.2, if you want support, you have to move to 1.2. So you can choose to stay on the slow path or the fast path. And so that's the way we're going to ship this thing. Let's go back and see if that Windows container ever started. I'll give it one more shot here. If it doesn't come up, I will kill it, and I will show you the tooling we have for Linux containers. I'm not feeling the love on this thing, so. Okay. Now, the nice thing about Docker is I can just go clean this up. Here's the process. I can say, okay, stop that process. Don't want that to run anymore. I can then say, remove it. Container's gone. Docker images, I can say remove the image, my app, actually 2.3. I've cleaned all that up. So that's the cool thing about containers is because they are kind of fancy VMs, they're very easy to clean up. They don't destroy your machine. You can try stuff, and you're in good shape. So what we're going to do now is I'm going to switch and open a different project. Go up here. And this is a ASP.NET Core MVC application. And I made a small change to it as well, just like I did for the system web one. I've added a little bit of code to this thing, so when it runs, it will actually show me the operating system that it runs on. And we'll just run it here just to see that it runs locally. There you go. And you can see up here, it's basically saying I'm running on Windows. Now, I want to do container development, and as I was saying before, we're going to have great support for container development in Visual Studio, because that's what most of our customers do. So I'm going to right-click on the project. I'm going to say Add, and there's this item here for Docker support. I'm going to click that, and a couple things happen when I did that. If I look at the files in my project, you're going to now see here's the Docker file for this. It looks a little bit different because it's using .NET Core. And you're going to notice also that my run changed into a Docker button. I can always decide to change that and run it on IS Express and stay on Windows, or I can decide to run on containers. So let's go look over here. Now if I say Docker images, you're going to see I'm on my Linux containers. So we'll just run this. And all the stuff I was doing on command line is now being done by Visual Studio. So it's basically building the container here. And you're going to find .NET Core is a lot smaller than System Web and .NET Framework, full framework. And so this is pretty fast. And so you can see now it's waiting for the container to boot up. And I'll just go over here for fun, or waiting for it, and say Docker images. And you can see here's my application running here. Well, it's popped up. Here's my application running here. Here's my container. I can do a Docker PS -A. I can see that container running. And you can see the apps running just like it normally would, but you can see that I've now got the Linux up here instead of the Windows. Now what's cool is this stuff is really, once you get it going, it's actually really fast. So let's run the app again. And boom, I'm back in. Even better, we have full support for debugging containers. So I'm actually on a Windows machine talking to a Linux VM on my machine, but the debugger will actually still attach and remote debug. So I can come over here. Let's go add a breakpoint to the About page here. I can start the debugger up. App's going to boot up here in a second. And once it boots up again, I'm now running on a Linux image. You can see what it's doing here is the debugger's running, so it's loading symbols. Take a bit more time the first time. I click About. Boom, I'm on a breakpoint in a container. And this is part of what you're going to see us continue to do in Visual Studio. There's a whole push we have to make containers awesome and easy to build in Visual Studio. The next thing, which we'll demo in a few weeks from now, is I'll be able to right-click and publish that container to something like the Docker Hub. The next thing we'll do is let you build microservice types of applications with this. So we're going to make containers awesome and easy to do with .NET Core. So let's jump back here. I'm going to skip Xamarin today because there's mobile talks talking about that today. And I want to talk about .NET Standard. When I joined the .NET team early this year, the one thing we kind of looked at is we have lots of .NETs. We have .NET Framework, we have .NET Core, we have the Xamarin technology, and these are all different .NETs. For example, if you use .NET Core, there's a bunch of missing libraries like XML and serialization. If you use .NET Framework, of course, you pretty much have everything. We even built other versions of .NET. Everybody's seen Silverlight, and there was .NET Compact, there was Windows Phone 8. There was a whole bunch of .NETs. And the challenge we had was, if you were going to use those .NETs, they're all different. And if you want to share code across them, it's even harder. We had a technology called portable class libraries that we created for sharing code. And the negative of portable class libraries is you basically go into a project and you check which frameworks you want to support. And as you do, the number of APIs that you can have shrinks. So the goal with .NET Standard Library is to have one big chunk of .NET that's consistent and common across all of .NET. So as the slide says, learn one API, reuse code across all the .NET platforms, and easily consume third-party libraries. So, and this is a change for us. When we actually first started building .NET Core, it was meant to be, hey, we're going to take all the stuff that we don't think you need for web apps and take it out. But then it made code sharing and stuff really hard. And so this is kind of a change of strategy for us. So next year, early next year, we're going to ship .NET Standard 2.0. And this is when .NET Core is going to be a lot more interesting to folks in the room because that's when a bunch of APIs are going to come back. And the idea is, as I always like to tell people, is I hope in the future you don't target .NET Framework or .NET Core or Xamarin. You build .NET Standard APIs and .NET Standard applications. So you're using this big chunk of .NET that's common across all of our platforms. And that's also where I hope to add new APIs. So when APIs come on in the future, maybe they're not added in .NET Framework or .NET Core, they're added in .NET Standard, which means they're everywhere all at the same time. and we can ship .NET Standard as NuGet packages, so you don't have to wait for a framework to ship on an operating system. This shows all the stuff coming back. If you played with .NET Core and found there was a bunch of missing libraries, this is all the APIs that will be coming back as part of .NET Standard. As I said before, all the XML, all the serialization, all the networking, all the I/O, threading, a lot of core BCL stuff, all is coming back. It's going to be an awesome world where a NuGet package in the future just targets .NET Standard and runs on all the platforms. This kind of just shows the interop that we have here, where your full framework application, your core application, your Xamarin application all talk to the standard library, and they can also still consume existing libraries. You could take a library from 2002, and it would technically work in a .NET Standard application. Your existing portable class libraries work in this world as well, and so does the any existing .NET Framework library. So super cool, super happy about this. It's going to be awesome. Next area I want to talk about is Visual Studio 15. There's a whole bunch of stuff we're doing here, and we'll start with this one. I'm sure everybody in the room here is using Visual Studio. How many people like the amount of time it takes to install? No hands? How about installing Windows Visual Studio updates? How long does that take for somebody's machine? An hour, 2 hours? So let me show you something here. So there is a new installer. Its codename inside of Microsoft is called Willow. And I'm loading it up right now. And I know people in the room have probably done this before. You've gone, hey, you know what? I'm just a .NET developer. I don't want any C++. I don't want any mobile. I don't want anything else. And you uncheck everything except .NET, and you get tons of stuff. The goal of the new installer is a couple things. We are going to finally give you the granularity to turn off stuff. If you don't like Visual Basic, you can uncheck Visual Basic, and there won't be any Visual Basic. You can turn off anything that you want. So I've got the installer running here. It's showing a couple of the major workloads. I've got .NET Desktop Development, but I can also go to individual components, and I can tick on or tick off anything that I want. So as I was saying before, I can just turn off anything. If I don't want F#, I can turn F# off. So the idea here is basically to give you a lot more control over what you install in Visual Studio. Another idea behind the new installer is, today when you install Visual Studio, it touches your whole box. I mean, does anybody in the room believe if you uninstall Visual Studio, it's really uninstalled? Everybody's laughing because I know you've tried to do this before, and you're like, hey, I removed it, and my add remove programs shows like 30 things left, and I'm not sure what I can actually remove from that because I don't know what will break. Another goal of the new installer is to actually take all those components, put them in the Visual Studio folder. We even take the registry for the new installer. When something touches the registry, it doesn't touch your global registry. It touches a registry that we have in our folder. So the idea is you can actually install Visual Studio side by side and just nuke the folder to get rid of them. There'll still be a few components that actually are kind of globally installed from partner teams that are more OS-y kind of components. But that's kind of the change with the new installer. Scott Hanselman and I did a demo at Build earlier this year where we actually installed Visual Studio from a memory stick in under 1 minute on a box. So I think what you're going to find is you can turn more stuff off, the size of Visual Studio and disk will shrink, and the install is going to be a lot faster than it was before. So that is the installer. Everybody in the room, I'm sure, has been using Visual Studio and complained about, hey, it's using a lot of memory, or my fans on my computer are running full tilt. I feel like my machine's really heavy. A huge push that we have in Visual Studio is, in this time, we call it the perf epic internally. That's what our internal teams are. We've gone through Visual Studio, and you're going to see the amount of memory it uses be cut down dramatically. The amount of CPU that it uses cut down dramatically. It's really tough. We're building some new .NET features, and I roll into a room, and they're like, how many megs do you need? I'm like, I need 10. And they said no. I mean, basically, there's kind of a committee that's holding us and saying how much memory you're using, remove memory, reduce memory. There's a cool feature as part of this. There'll be something called deferred solution loading. You can enable in Visual Studio. When you do, if you open a project that has a solution with a lot of projects, we won't load them, we won't make you wait for the entire thing to load. We'll background load them and you can get to work right away. So there's a lot of work done here to do that. We have a whole bunch of productivity stuff that we're doing. Who in the room uses ReSharper? Good Lord. Do you want to continue to use ReSharper, or would you like us to put the ReSharper features into Visual Studio? Put it in Visual Studio. So you will see that we've got most of the top ReSharper features will be in Visual Studio 15. And once again, as I talk about memory and stuff, ReSharper uses lots of memory in Visual Studio. And so this will be a way that you can actually reduce memory again, is by doing that. Another cool thing we've done is we changed our compiler technology a couple of years ago to use Roslyn at the last version of Visual Studio. That's our C# and Visual Basic compiler. As part of that, it actually has the ability to do code analysis as you're actually typing code. And so you're going to see a lot of things like the old FXCop come back. But this time it won't come back as a tool you run on your code. It actually happens as you actually type and do your code. And even better, when it finds an issue with your code, you'll be able to basically look at the squiggle. It'll actually show you the recommended change for your code. If you push a button, it'll actually change and fix the code for you. And so by using this feature, we'll give you a whole set of rules that you can actually apply to your code. And that'll be pretty awesome as well, I think. And then this is something where .NET Core and .NET and ASP.NET come together. We want to be the best tool for containers and microservices. That was some of the tooling that I was showing you before for building containerized applications. You're going to see us in the ASP.NET space. You're going to see us take ASP.NET to the next level and actually let you have microservices in ASP.NET. So today you can build a MVC application or a Web API-ish application. That's still got a lot of stuff going on under the covers. We will give you the ability to build super small applications for doing APIs and stuff like that, which should make your productivity go up as well. So let me do a couple other demos of cool Visual Studio features. So close out some of this stuff. This is something that's actually shipping today, but it's pretty cool. From the web team, one of the nice things about the web team is you can take your application, get it running, and just go to Visual Studio and change the code while the app is still running, and just refresh your browser, and you get a pretty good experience there. We're taking that same experience to WPF as well. So today what you probably do is you run your application, you look at it, and you go back and work on your XAML and change things around. If you have the current version of Visual Studio installed and you're on update 3 or later, I believe, I'm running this application. Here's David on my team. I've got this new tool because I'm debugging, and this is the selector tool. And now I can select things on the screen. You can see stuff kind of highlight as I get there. I'm going to click on David Carmona, and then I'm going to say, go to the live visual tree. And so what happened there is Visual Studio went and found the exact XAML that I had selected and brought it up live here. Now I can come to that XAML, and I can click on it, and it's actually taking me exactly to the element that you see on the page here. Now what's cool is I can come here and change the XAML. So let's change the font size to 1 and move back over here. Boom. 10. 100. And so you can actually live edit your XAML in Visual Studio, and your app will actually refresh in real time as that happens. And it really is real time. So I moved the wrong one? I did. Now they're both here side by side. So that's taking web kind of tooling and bringing it to the XAML world, which is pretty cool. Another one that I have that's interesting before I get to some cool language stuff is, let's just say no. Is anybody in the room aware that we shipped an interactive console for C# and VB? I see one hand, a few hands. So at Microsoft, a lot of us spend a lot of time using the tools and technology And one of the things that kind of comes out of that is, I'm sure everybody in the room has built lots of little console applications because they want to try stuff out. What's really cool is there's now a new window I have. Here's my C# interactive window. And I can just start writing code in here. I can even write functions in here. I could have a thing here, and I could say this returns I plus 100. There's my function. Now I can say console, that right line, and I can say, let's call foo, pass it 100, and we should get 200 out. And so I typically show this to people, and they go, that's kind of cool. I could, so the idea is you can just experiment and try code out, but this is kind of too basic because all my app's not in here. What if I had an app and I wanted to actually call the interactive console against my application? I can do that too. So let's come over here, and I've got a simple app. Interactive. Got a simple app here. And it's got this util class, which is a version, it's basically the same function I just wrote before. But now what I'm going to do is I'm going to right-click on my project, and I am going to say initialize interactive with a project. So imagine today you've got a class library, you've got an application, and you just want to try some of your code out without running your app or experiment around. I now have access to all the code in my application in the interactive console. So I can say interactive, actually I don't even have to, I don't think it's, namespace is already there. Utils dot superfoo 100. So I launched the interactive console, and I'm actually running code directly in my application. So it's a great way to mess around and try some stuff out. The next thing, and I've got a slide here, that this is one of my favorite things to show off is as part of the previous version of Visual Studio, when we switched to the new Roslyn compiler, that's our C# and VB compiler in Visual Studio, the nice thing is it means that we can actually ship language support at a much faster pace. So historically, we've revved things like C# and VB every 1 or 2 years. I want to get to a place where I can actually rev the languages a lot faster. And so we're going to ship the next version of C# with Visual Studio 15. And then after that, I hope that we actually release updates to C# and VB every couple of months, every 6 months or so, versus the multi-year that we do today. F# kind of ships outside of the box a little bit, so it's got a faster velocity already. And our real goal is we're going to lead with C#, meaning that we're going to add new features to C# first, and we'll make sure that we actually move those features to VB so you can interop any of the new features both back and forth from C# and VB. So let's try some of this out. Okay. So I've got a simple app in here called Showcase Tuples. And Showcase Tuples shows one of my favorite features that we're adding to C#. And I'll show a couple things here. This is your typical kind of app. Don't need the Roslyn window. I've got a function here that returns a result. And because the result's more than a single item, I created a struct called result for that. I'm going to do something different here. I'm going to enable tuples. This is a thing you have to do today. This will go away in the RTM of the product. I actually have to go and search for this thing. There's a NuGet package called system.tuples. And if I install that, Actually, let's not do that one. Let's do value tuples instead. There you go. Oh. Let's install this in my application. And this enables support for tuples in Visual Studio. And I'll show you what that does. So let's go over here. And I'm going to change my application. I don't want this struct anymore. So I'll comment that thing out. And I'm going to make this instead. That returns a int sum and an int count. This is a tuple. And so instead of creating these structs in CRUD that we just keep around and throw away, you can now actually make any C# code or VB code actually return multiple results. So I can come down here, and we'll just say, return sum and count. There you go. And what's cool is you're going to see that all my IntelliSense works the same way as it always has. Notice here it knows that I've now got a local variable that is a sum and a count. It's all that tuple. And if I run this, it should still run. Good. So that's part one. There's another feature that we did called interpolation that we actually added in C#6, which exists today. I'm sure we've all in the room, we've done this thing here, where you've got the 0, the 1, the whatever, and you have to, once you get to the point that your stuff scrolls off the side of the screen, you have no idea what counts are. This is already shipping today. You can use this today. All you do is you come over here, you put a $sign in front of this guy, and now I would say r.sum here. Full IntelliSense, r.count here. And I no longer have to worry about 0, 1, 2, 3, what number I'm at, where it goes. Once again, this should still run. Good. We also look at other ways we can help you out as well. So if I look at this code, what if I change this to an object? Let's say I want these to be object instead of being ints. I make this change. And because I made that change, now my code doesn't compile. And I would typically do something like, hey, if v is int, then let's run this code here. That should fix it. Oh, I need to, now I need to create another, so I need a foo, which will be the v. Typecast v to an int. And then I could add the foo to this. So I can do stuff like this. Once again, we can do shortcuts. I could just let you name the thing there and do that. So you're going to continue to see us add new small things here and there to do this. Other things that I'm not showing demos of, we also have the ability now for you to write functions inside of functions. You can have nested functions, which is pretty cool. Did I make it unhappy? What did I actually do wrong? So those are some of the C# features that I said are coming, and we have a ton more of that stuff to happen. Let's go back and show a little bit more of .NET Core while we're sitting here. So let me make a .NET Core application. let's call it web application 2, that's fine. I'll select regular application, and I'm targeting .NET Core with this application. And as I was saying before, one of the big benefits of .NET Core is we want to enable you to be able to write applications that run on a variety of platforms. So it's restoring my application. We'll just run this. Just regular ASP.NET application. Now I'm going to show a couple things here. So app's running. So let's go find the actual app on the disk. So here is the path to my application. We'll just jump to that. So here I am in my application. And as I was saying before, these apps are actually fully cross-platform. I think Scott showed some of this stuff yesterday. You've got your .NET folder inside of program files. But what I can do now is I can just say, .NET publish. And what this is going to do is this is going to go build my application in a format that is ready to be copied to a server. It might complain because I got VS running that it thinks the app DLL is actually stuck. Let's give it a second, it'll settle down, and it should go. Yeah. So what's cool here is I can go into this folder, and this actually produces the output of my application. So here's the publish folder, and this contains all of the parts of my application that are required to run. So you see all the DLLs that are required as part of the application. This is a self-contained app. And what's cool is I can take that self-contained application, and it will run on any machine that has .NET Core installed on it. So what I can do is I'll just take the publish folder here, and we will just copy it onto my memory stick. Happens pretty quick. Now we'll come over to the Mac. Let's do it over here. Give me 1 second. Better. Good. So now, on the Mac, give me a second to get this in better shape. We can go to the memory stick. It should be sitting over here. Mac's funny, you have to list the folder twice. I can go to that publish folder that we just had, and I can say, shrink this down a little bit. I can run the .NET command and give it the name of the DLL for the application. And you're now seeing that boots up. And there you go. There's that application I built on my Windows box, running directly on my Mac, copied off a memory stick. What's cool is I can take this demo and make it even crazier if I wanted to. Let me go look what I've got over here. Today, that particular application depends on the .NET SDK being installed on my Macintosh. So for that to work, I had to have that SDK installed in my box. What if you don't want to have the SDK installed on the box? You don't have to do that either. So if I look at my .NET Core application, it's got this project JSON file that contains all the settings for it. And one of the things that you see here is you see this text that says type equals platform. What type equals platform means is it means it's terribly misnamed. Hopefully we'll fix this in the future. Type equal platform means I want to use the shared .NET on my machine. And that would have been what Scott would have shown yesterday, which is, hey, I can go to CBAC, go to Program Files, .NET, Shared, Microsoft Core. So you're going to notice in my project JSON, this is this Microsoft Core app. Here's Microsoft Core app right here. Here's the 1.0 version. And so type equals platform means I expect you to use the one installed on the box. Now I can take that type equal platform away, like this, and I can save, and then things likely will not be happy here. Boom. There's build errors. And there's build errors because as soon as I took that type equal platform away, we need to tell the application what platform to actually build itself on. Before, it didn't matter what platform it built on because it was using that shared set of folders that we expect to be on any machine out there on the internet. Now what I can do is I can add this to my application above dependencies. And so what this does is this is actually telling the system, here are the runtimes I want you to build. I want you to build me an OS X runtime, I want you to build me a Windows runtime, and I want you to build me a Linux runtime. That'll restore and do a few more things. Then what I can do is I can go back to my publish and I can tell it the runtime that or the runtime I want it to actually build me. The output of that will be an application that contains everything required for it to run. Does anybody have a Mac in the room? I see the guy in the front here with a Mac. Do you have .NET Core on your Mac? Terrible. Is anybody in the room does not have .NET Core on your Mac? So let's try this. You want to come up and try it? You brave? I don't have a volunteer that has one. Does anybody else have a Mac with no .NET Core on it? Okay. So what we'll do, let's see if we can get you projected here. That's the danger of live demos. Can I close that? Okay. So I tried to run the .NET command. You obviously don't have the SDK installed because if you did, that would work. So just give me 1 second here. And let's make another version of our application. And so I'm not going to project this, but what I'm going to do is I'm going to rerun the publish command, and I'm going to specify a runtime. Actually, I will project, just to show this. So I'm going to run the same .NET publish command that I ran earlier. This will come up in just a second here. And now I'm running .NET publish with a -r, and I tell it the OS that I want to actually run. It's going to do the same thing again. Okay. So now, let's go back to the memory stick, and we'll kill it. Kill the publish folder. By the way, I'm going off the rails here. I don't know if this will work, so thought I would just do something crazy. So let's go to the folder of our application again. I'm going to go in the bin, debug, core, publish. But notice there's something new here. There's the OS X version of this. And everything that we need should be in here. So let's take this publish and put it onto the memory stick. So it's going to copy a little bit more stuff because I'm now copying all of the .NET framework required for the particular application. And I'm doing the Windows to Mac thing just to highlight this point. But the point is you can take your .NET application with nothing installed on the server and run it on the server. So let's pull this out. We'll switch back to the Mac. Okay. Let's go find the memory stick. Hello. It's right. I find Macs to be twitchy when it comes to, it just showed up. Your Mac refuses to show anything on the memory stick. There it is. Actually, let's try this. Let's do Apple Terminal. This is the one you had. You zoom this in a little bit. Let's go to publish. Okay. And there should be so I just found the actual application. I'm running it. Application is started. I'll let you go bring the browser up and go to localhost 5000. You'll take a sec. Go back and look at the terminal. See if there's any output coming through. It looks like it is running. Application started, request. Da, 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 da. Ah, yes, I know why this doesn't work. Okay, so I'm not going to kill your machine. So the reason that doesn't work is we require OpenSSL to be on your machine, and you don't have OpenSSL on your machine. So if you go to the new .NET site and you click on Mac, you're going to say the first thing it shows you here is I need to install OpenSSL and set up some symlinks for it. So let's do that. Do you have brew installed? Looks like you do. So this is actually a dependency that .NET Core actually takes today. Are you on the network as well? Yeah. Today, .NET Core takes a dependency on the OpenSSL library, and so it requires a component to be installed on your operating system. In the 1.2 time frame of .NET Core, we will not take a dependency on any externals. We're going to compile all of our external things directly into the framework. So you won't have to actually have any third-party dependencies on your machine. But today, the only dependency you'll have is basically the, let's just try, looks like you do have it. This is downloading OpenSSL. Boom, 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 boom. Once that's there, let's grab this. These just create symlinks to the library from that. There we go. Let's do one more of these. You guys know this is real because okay. That looks healthier. Ooh, yeah. So there is still no .NET on your machine. It's running purely off the memory stick. You could go take that app into a server farm, stick this on your machine, and your app runs completely self-contained, nothing external, it just works. And that is a key tenet of .NET Core, and one of the things we want to really do is even if you're a Windows developer and you're building Windows applications, you can take the latest version of .NET Core, the latest versions of ASP.NET, the latest versions of EF, run them on your machine without affecting any other thing on the environment. And that's one of the core tenets of Core. Thank you very much. We demoed the tuple stuff already. I might show one final thing before we go. I think Scott could have shown some of this yesterday. Did Scott use a Macintosh yesterday at all? Hanselman? In the keynote? He did? No? Yes? No? Give it 1 second to show back up. So obviously another key tenet of what we want to do is I want people to be able to build .NET applications on any device. And so I can do .NET New, which Scott did show yesterday. There's my application. I can do .NET Restore. Goes grabs my packages. .NET Build. Builds my application. .NET Run. All there. That's kind of cool. But I can also bring code up. Again, let's make it bigger. And notice it says, hey, if you want to build and debug, I need to get some more stuff. So it does that. So here I'm in VS Code. Now what's cool is I'm on a Mac, and I can still come over here and run a debugger. Yeah. Bingo. And so this highlights the point too, is we want to make .NET Core something that's approachable for anybody. So Windows, Mac, Linux, you can just use Visual Studio for Code on those platforms. You get all the debugging, IntelliSense, all the same stuff that we have. Everything we can do in Visual Studio with menus and buttons and dialogues, you can do from command line. And so you can easily move back and forth between these things. Which is super important to me as well. I want .NET to be something that anybody can install. You don't have to go install, Visual Studio to get this thing. If you just want to hack with Notepad or hack with Vim or Emacs or whatever it is, you can. That's a key tenet of .NET Core. So in recap, .NET Framework, we will continue to invest in. It will ship as part of Windows. .NET Core, cross-platform, microservices, containers, ASP.NET, Xamarin, iOS, Android, Mac OS X. .NET Standard is going to let you take all of those things and use the same .NET on all of those platforms. You get .NET Standard. All of our languages and stuff work everywhere for your .NET stuff. Tooling for containers is coming. A lot of ReSharper features are coming into Visual Studio. Smaller, faster, better memory utilization, all coming into .NET. And that's kind of what we're doing for the next couple months. Anyways, I can take a few minutes, like 5 minutes worth of questions, if anybody has any questions on .NET and the platform and where we're going. If not, thank you guys very much.